I can like look at this compound, which is vanillin. It's the compound, like if you were to take vanilla beans and extract out the organic component that like gives you the vanilla, smell, taste, this is what the compound would look like. Now, I'm sure that, I don't know, can you guys see a lot of different functional groups here? Like, look at all the functionality in this compound. Look at this. I see an aldehyde. This is an aldehyde. I see an aromatic ring. I see a phenol. I see an ether. Like, there's so much here. 2-octanone is the compound that's responsible for mushroom flavoring. Benzaldehyde, if you were to smell this, it would smell like almonds. Cinnamaldehyde is this compound right here. It smells like cinnamon. You've got an aldehyde, an alkene, an aromatic part. So there's like lots of different functionalities that plays into this particular compound.
So did they like name these foods and stuff based on the compounds, or did they name the compound based on it being in those foods?
It's probably food first, because like, imagine, I'm assuming that it's food first, because trying to analyze the structure of a compound takes kind of like more mature instrumentation, if you will. So I'm pretty sure cinnamon was around before that kind of stuff.
Yeah.
So, but that's a fair question. I love questions like that, because that's kind of how my brain works. Well, this is the structure of lemongrass. Lemongrass is also an aldehyde. Alpha damascone is a berry flavoring. I've shown you this structure before. I showed you this in the alkenes chapter to say, hey, look, there's a bunch of alkenes, but hey, look, there's also a ketone. So there's all kinds of functionalities here. And of course, there's reaction. So what if we're in the lab and we need to make an aldehyde or a ketone? There are synthetic strategies that we need to use in order to prepare these things. So when we say preparation of aldehydes and ketones, that just means how in the heck do I make these things? So we're going to go over how we can make these. And honestly, you guys have seen this reaction before. However, it's just a new way of looking at it. We are going to oxidize alcohols. So if you remember those terms from last week, we looked at the reactions of taking an alcohol and oxidizing it. Primary alcohols made aldehydes. Secondary alcohols made ketones. And then remember, I mentioned tertiary alcohols do not oxidize, and I will definitely put this on exam 2, because it should be no reaction. We cannot oxidize tertiary alcohols. So you've seen this before, where a primary alcohol is oxidized to an aldehyde. We simply are going to have a removal of 2 hydrogens. So for instance, I can just remove these 2. If we remove those, and what we need to do is oxidize the alcohol to form an aldehyde. So this is an aldehyde. Does anyone remember one of the compounds that performs this oxidation? So O in brackets means oxidation. I mentioned that there were two routes for oxidation to occur, like two different compounds. Anyone at home know?
So you said two different types of reactions with this, or is that what you said?
Yeah, so when we were talking about alcohol